Okay, I press start. Hey Martin, do we look the same? No. No?
No.
You've gotten that before? I don't know. Who? I feel like who looks the same? Yeah, me, you, and then what? What is this? What do you think? We did shadow clone YouTube? Yeah, we were shadow clone. We're gonna go back to the gym. I have to do that right after this. Are you gonna stay? I'm gonna stay over. Yeah. You're gonna stay over. Stay here. Hello. Hello.
Welcome.
Hello.
All right, 4 o'clock. Let's wait 5 minutes for people streaming, and then I'll start.
I have the Collab open too.
Yeah, I know. That's for later.
Jupyter Notebook, Collab. You have to download it. It's still in Notebook. Isn't Collab in Notebook?
Yeah?
You don't have to download anything.
No.
Jupyter Notebook.
Yeah, for Jupyter Notebook, you do have to download stuff
Yeah,
though.
you need to set up the environment on your notebook.
I mean, if you have VS Code and you have the Python extension, it does it for you.
That is true. I never set it up though.
Wow.
I just do it
Nope.
on
So
browser.
no Python?
On browser. The notebook's on browser.
We can't be friends, Buster.
I don't know how to set it up on VS Code.
Bro, you literally just get the extension.
I have it.
It's the first extension on it because it's so popular. Come on.
I'm confused. So I have an icon on the Jupyter Notebook, so I don't need anything else, right?
Yeah,
Yeah, okay.
you're good. Do you have Tensorflow?
Which one?
Tensorflow.
I don't think so.
Then you should probably get on the Collab then.
Yeah.
We're only gonna do one example of the hello world, and then I might go into like making a neural network with some made up data.
On Collab.
Installing Tensorflow is a really big pain in the butt though.
Isn't it just a exclamation mark pip install?
It's not that easy sometimes.
Let me see. I'll do it in
Because then if you want to use GPU, you need to have like a certain version of TensorFlow, and then you have to have the CUDA drivers installed. It's a pain in the butt.
That makes me not want to install it.
That's why I'm using Collab. Hey.
See, yeah, right there. Just pip install. Oh, that's beautiful. In the Collab.
Beautiful.
It says requirement already satisfied. So.
But it's already installed in the Collab for you, so.
Yeah, that's beautiful.
If you do exclamation point pip list, you can see all the libraries that are installed in the Collab.
But the GPU in Collab, that's cloud-based, right? Those are.
Yeah, so you need to actually go to manage runtime and select hardware acceleration as GPU to actually use it. It's like a whatever GPU that Google gives you. They do, but there's a lot of people that use that. All right, 4:05, so let's get this started. So, hello everyone, my name is David Yanyo. I'm going to be your host for this workshop. I'm from Google Developer Student Clubs. I'm the artificial intelligence lead over there for the developer community. Here's my Discord @ if you have Discord. I'll share our link to our Discord later. So today I'm going to be talking about an intro to ML, aka hyped up math. So let's get this started with the agenda that we're going to have today. So first I'm going to go over what ML is. Then I'm going to go over why ML is what it is. The difference in logic between human and AI. We're going to go through a hello world example. And then I'm going to outline where to start with ML. And then we'll have a Q&A for you guys. All right. Oh. Right, there we go. So what is ML? I put in a subtitle there, hyped up math. So straight from Google, it's a use and development of computer systems that are able to learn and adapt without following explicit instructions by using algorithms and statistical models to analyze and draw inferences from patterns in data. All right, so that's a big mouthful. So let's have a caveman definition. And this caveman definition is make computer brain with math to learn patterns. That's it. Very easy to understand, right? So why? Why do we have ML? Well, in the beginning, there was lines. When AI was first created, it was just an easy way to make a line of best fit through a graph of data. So ML was and still is the algorithms that AI used and uses to make the models learn. And the models here are the computer brains that I was talking about in the previous slide. So AI is philosophical. You'll see a lot of people, when you search up AI on Google, you'll see a lot of people like, oh, we're close to AI intelligence, general intelligence taking over the world. But ML, it's more practical than that. When we talk ML, we talk about we need to replace traditional programming with ML models or computer brains that can do what traditional programming can do right now, but better. So ML, it's mostly probability theory. This is the math I was talking about, probability theory, statistics, and linear algebra. some of these, some of the things you'll see when you get into ML is regression. It's where your computer brain takes in data and spits out a number based on that data. So let's say you have data like the height and weight of a person, and the result is, okay, a 0 or 1, this guy will be a basketball player or a football player. And that's kind of regression. Another one is, here's some data from a house, predict the price. That's regression. You'll have like a couple of features for that house, like number of rooms, number of bathrooms, and then the brain, after being trained on other data from houses like similar, will be able to see, okay, this is the approximate price for this. Clustering, this is basically trying to group up data in certain points. So let's say you have a graph of data on, let's say, items on eBay. This was actually a challenge that eBay put up. You want to group up these items in their own categories, but you don't really have like labels for them yet. So there's clustering algorithms, which is ML, that can do that for you. And then there's classification. This more fits into the basketball or football example that I put, but this is also goes into computer vision. We're trying to classify whether an image is like a cat or a dog, or a football or a soccer ball. I know some people call it football as well, but we're in America here. Hot take, I know. So let's go into the logic differences between a human and ML. So human brain versus computer brain. So here's the human brain. So as humans, we take in input through our eyes, our senses. So let's say the data that we're getting in is a cat video on YouTube, where the cat has a funny dress on, like bunny ears or a tutu. So our rules that we've inherited and nurtured is that animals equals cute. So the result of that is that we say, ah, all right? But here's how computers are. So let's have the data, and we're not talking only about the data, we're talking about a label as well. This is for supervised learning. A cat video on YouTube, like we had before, but we also feed in the result for this data to our computer brain. So now the computer brain will learn that if it sees a cat in a funny dress, the result should be ah, right? And that's what it spits out as the rules. And later on, when you finish training the computer brain on this data, which is the cat video and the result for this data, you can actually use it for data that it's never seen before to actually predict. And that's pretty much the way. All right, so let's get into the hello world. All right. So for this, I'm going to be using Google Collab. If you haven't heard of it anymore, it's a notebook online. It already comes pre-installed with a bunch of stuff. I'll show it right now. If you do a quick, sorry, not my computer. We do a quick pip list, and you press the what this does is that it shows all the modules that Python pip has installed in this Collab. And you can see it's a lot, but the most important thing here is that it has Tensorflow, the latest version, and I'm pretty sure it has NumPy here somewhere. Yeah, here. But enough of that. Let's get into it. So we're not going to use pandas for this example, so I'll delete that. But we're going to be using our TensorFlow that's installed into Collab. We're going to be using Keras. This is an API that TensorFlow has to create models. And this is our computer brains, the models. And then we have NumPy, which we're going to use to create our data. So let's execute that. A shortcut to execute a cell or this block of code, that it's called a cell, is Shift-Enter. So you don't have to press the play button every time. Now let's create our data, which is not the result, just the data, our cat video, for example. Let's have an array -1, 0, 1, 2, 3, 4. And we'll use the np.array function to create this array. And we'll have the data type equal to float. For the models or the computer brains, they do not like integer data, so please use float. And let's have our computer brain learn the pattern 3x plus 3. So we're going to create our resulting data. So our model, we want our computer brain to learn 3x plus 3. So for our result data, we want it to be -1 into this x, and 3x plus 3, that's 0. 0 is 3, 6, 9, 12, 15. So as you can see, this is the pattern here that's going on, that we've created. And we want our computer brain to learn this pattern. So let's actually make that computer brain right here. For this model, we're going to be using the sequential model. This computer brain is the one you see all the time in pictures with the layers. You know, when you have a neural network, you have the dot and a couple dots and a couple dots and the final dot. That's basically what it is. It's just layers. And we're going to have one dot in the middle. So it's going to be, if you can have this in your mind, or imagine it, it's going to be 3 dots all together. So the first dot is going to have our data and results into it. Our middle dot is going to be the computer brain, which is going to learn the pattern 3x plus 3. And our resulting is going to be, hopefully, whatever it thinks the pattern is, hopefully 3x plus 3. And we can output our model summary right here. Here it is. This is here it is. We have our dense layer. It's 1, so it's going to be 1 dot. And now we're going to compile this. And what this means, compile, it means we're getting our model ready for training. So it's getting ready to get in data and results and learn the pattern. So what do these parameters mean here? Optimizer. So the optimizer is what's going to fix our computer brain. And the loss is what tells our computer brain, all right, this is how off you are. So let's say the computer brain, the model, starts training. At first, it's going to be pretty random. So it's going to get in the data. It's going to say, all right, let's say for 1, it's going to start off with like a pattern of 0.5 or something like that. And then its output is going to be 0.5. So the loss function is going to say, all right, this is how off you are from the actual result, which is 3. And then our optimizer is going to go back to the computer brain and fix it a little so that it's a little bit closer to the pattern that we want. And now, let me run this. And now we're actually going to train it. So as we said before, we're going to feed in our x and y, which is our data and result. And we're going to do that cycle of putting in the data, seeing the loss, and then optimizing the computer brain to get our pattern. And we're going to do that 500 times. And that's what we call epochs, that cycle. And as you can see, the loss actually gets less and less and less as the pattern is learned. So it's pretty close to 3x plus 3 right now. So let's actually predict it. Let's use our computer brain to predict. All right, we're going to give you 6, and the number should be pretty close to 3 times 6 plus 3, which is 3 times 6, 18, plus 3, 21. So let's see how close it is. 21. It's pretty close. All right, I'll do it again. It's pretty close. So our computer brain, it's pretty close, but it's not exact. And that's the problem you'll see when you get into ML, that the models are never 100% accurate. So that means they'll never learn the exact pattern, but they get pretty close. And that has to do with probability theorem that is in ML. It's actually, the model isn't really has this pattern like 3x plus 3. It's more of a prediction that it's doing, or it's something, it has a number in its weight or computer brain that it multiplies by the input to get the output. So it's not really exact. All right, we can do this one more time with another number just to show you this one more time. Ah, man. Yo, that your computer blows, bro.
What are you talking about? You're probably
Oh my.
do command.
Command. This is a Mac, bro.
It's a Mac. It's like the Windows key. There we go. That's all I got.
All right, let's do another prediction here. All right, 8. Let's do 8. Again, this is not a number that the model was trained on. It's completely outside of what it was trained on. So let's see if it can actually get it. So 3 times 8, that's 24, plus 3, that's 27. See how close it is. It's pretty close. It's pretty close. And remember, this is not data that the model was trained on. So this is the pattern that it learned.
So I guess with more iterations, it can converge closer to 0.
It'll get closer and closer to 0, but it'll never get to 0.
Yeah.
It's like the limit doesn't exist.
Yeah. Asymptotic. You got an error in the model fit line.
Model fit?
You got it? I got it.
It's
exactly right.
Is it the X, Y epochs? Did you compile it?
Yes, and I got, I changed the data.
If you get nan in the loss, it means you probably put in integers.
Raised value error. Data cardinality is ambiguous.
Data cardinality. That has something to do with that dimensions.
Y is sizes. What's Y?
Y it should be 2 vectors, meaning 1D arrays.
I skipped 9. We skipped a number.
It was a different area.
Number. It's a one-off. Okay. Okay, now what's going on? I don't know.
All right, let me actually share this.
Mean squared or square root? Mean squared. Error. Okay. There we go. It works now. So, David, question.
Yeah.
Do you recommend more epochs or more data?
So here's the thing with ML. The end goal is not, the end goal of an ML model or computer brain isn't so that it knows exactly what to do with the data it's been trained on. Because who cares about the data you've been trained on? You want your computer brain to be good at data it's never seen before. So when you actually do that cycle of training it over and over and over and over with the 500 epochs, you're actually overfitting it to the training data. And what that means is that it's only good with the training data and that's it. For this simple model that we have here, that's okay because we're not learning, let's say, a very complex pattern. We're learning 3x plus 3. That's not really complex. But if you go into computer vision and you only have training, let's say you only have training data and your task is cats and dogs, and you only have training data where the cat is in a white background. If you overfit your model in that scenario, every time there's a portion of white in your picture, the model will say, all right, this is a cat. And that's bad. That's really bad. So yeah, general models are good. Overfit models are bad. And there's also such a thing as underfit. This is where your model didn't really learn anything. And that happens when you have too few epochs, or let's say we did it only, I'll show you guys in action. So let's say we only did 15 epochs of this. All right, let me initialize it one more time because it's already fit. The loss is not that good because we didn't have enough cycles to learn that pattern 3x plus 3. So that's actually, when we go into the predictions, when we try to predict 6, it's kind of off by a lot. It should be 21, it's at 17. So it's underfit. The model's underfit. It didn't recognize that pattern. It didn't learn it. And you can see that in 8 as well. It was supposed to be 27, but now it's at 22. So that's underfit. All right. So now that you've seen the tip of the iceberg, let me tell you where to start on ML. So ML is big. It's really, really, really big. And if I was to do a workshop covering all the aspects of ML, it would be like one of those free code camp 12-hour ones. So it can't really happen. So where do you start? And this is the big question in ML for beginners, where to start, where do you go? So I'll show you. First, look up on YouTube, Andrew NG. And he has an ML course that goes over the math and the fundamentals. I'll put this in the YouTube chat for you guys. Yeah, the math is mostly linear algebra and statistics. It's not like the complex stuff. It's more like the beginning of each of those courses. So you don't really have to try. I can't chat. Why did you sign me out, bro? Yeah, it's this one. Let me share it with you guys. Yo, this is why I hate Macs, bro. This is the playlist. I sent it in the chat.
You're typing ML with labradoodle puppies and chicken tenders. Oh.
That's also a thing. So in computer vision, you want to actually have a lot of examples of that so that it can, because the more complex you want your model to be, to actually recognize or classify pictures, the more complex it is, the more data you need. So in our hello world right here, we didn't need that much data. We only had like, what, 7 data points and 7 results. But for a computer vision model, you need gigabytes of data, maybe even terabytes to have a decent one. Right, is this?
Wait for lab review and chicken nuggets. Chicken tenders. Yeah.
Chicken tenders, whatever.
Yes. It's like KFC bucket chicken tenders and leftover buckets. How to confuse ML.
I mean, people have tried, but computer vision models are more vulnerable to other types of trickery, like a pattern that it associates with one class over the other. So if you're, let's go back to that example with the cats with only white backgrounds. So if you were to give it a pattern like a white, like just a white piece of copy paper, the computer vision model that's overfit to that white background will probably say, all right, that's a cat. All right, so dog in a white background. Oh, he'll probably be really confused then. It might say 50-50. All right, then after you know the fundamentals, you gotta know a tool. What I suggest is you go into TensorFlow. I've already put in resources to learn TensorFlow in the Discord, and I definitely hope you join it after this. I'll show you the slide in a moment. TensorFlow is the tool that's mostly used in the industry, and it's pretty easy tool to pick up once you get like a course for it. Scikit-learn, PyTorch. PyTorch is basically TensorFlow, but more Python based. Even though I'm a Pythoneer, I gotta say TensorFlow kind of takes the cake on this one. You gotta figure out, so once you have the fundamentals, you know a tool, it's time to figure out what you actually want to do in ML. So there's a couple areas in ML. There's computer vision, which is working with images. There's NLP, which is natural language processing. And this works with text. So if you ever heard of GPT-3, that's text-based. There's DL, which is deep learning, and NN, which is neural networks. Neural network and deep learning are interchangeable, but I'll separate them just for the sake of deep learning being like the bigger neural network. Because that's what deep learning is, basically. It's a neural network, just bigger. And once you know what path you want to take, you gotta cover 3 areas or 3 stages of this model or ML development. There is data, model, and deployment. So out of these, I'd say data is the most important. Working with data is really a key aspect of ML. Here, you're learning where do you get your data? How do you handle it? What type of data can you handle? How are you going to feed it into a model? What shape you're going to have for it? That's important. You can also get insights from this data, get new features from the data. So let's say you have an app and you're trying to target Florida, and you have data for the temperature at days. So you have this temperature, and you have, all right, in this temperature, people go out. So if you find a pattern, let's say you go into this data and you try to find what temperature most people go out, and you can extract another feature from that. So then you can have temperature. People are likely to go out at this temperature, and people go out. So you can extract data like that. That's pretty important. Model. This is where you're making the computer brain. This is probably, model and deployment is where you're going to spend the least time. once you get into Keras or scikit-learn, making these models is pretty quick. Model, that's where you're using Keras or scikit-learn. And deployment, this is just to complete the entire pipeline. The deployment, you're actually are putting up your model for service. So this is where you're gonna host it like on a cloud service, and then make a website for it, make an API on top of it, so someone could like use your model actually, because what's the point of creating an ML model if people can't use it? You're basically done nothing. So that's important as well. All right. Man, when I press the arrows, the left and right, it skips. So. Oh, I guess I didn't have a Q&A slide. All right, so this is our QR code for our Discord. A and B, I don't know, maybe you want me to put your link here in the YouTube chat?
Wait, I think it's fine from my side. Yeah, let's pop the link tree. You never answered this.
It's touchscreen, bro.
Oh, it is?
Yeah. All right, there's a question. In Java? Of course, a Java Knight will put that.
No, I did all my pseudocode in Python. That's it? Only your pseudocode? I'm the lead code. Oh. Yeah. No, the last pseudocode that he's training me.
Oh yeah? Bro, there's no way a Pythoneer will put that in there. Yeah.
You know we never do that.
There's no way.
There's no way.
It has to be a Java Knight.
It would be. How many slides are there? Okay, this is their slide.
All right, so that's for A and B, for their Discord or WhatsApp chat.
Yeah, it's a link tree.
Or a link tree. And the next slide is for us, right?
Yeah, go back.
And this is for Google Developer Student Clubs, our link tree.
I have a question. How would you deploy it? How would you deploy a model?
So there's a couple ways that I know of. So TensorFlow actually comes with something like that. It's called TensorFlow Serving. It basically makes your model, it basically uses a local port to make your model a REST API. So you can feed it in data, like we did in the Hello World example, like 6. Feed it in a vector like a 6, and then it'll spit out a result. And you can also use, there was this data science blog that had an entire example for this. It was using Google Cloud, basically making an API with the model on the cloud and then querying like that.
So I guess the key takeaways for someone who would like to get started would be that they need the data first. So all data extraction, it could be from anything from vectors to images.
Yeah, for sure. Data is really important because the first question you should ask when you want to do an ML project is, what data are you going to use? Because if you don't have data, there's no way you can do anything, because then you can't train your model. And if you can't train your model, you can't deploy it, right? So you definitely need data. And if you don't have data, you gotta make it somehow. I know some people, what they do is that they first do a traditional programming approach. So they, instead of, let's say for example, housing prices, if they don't have the data for that, they'll make their own algorithm using like Python to like have a multiplication or whatever to get a sample price, and then they'll make the data that way, and then they'll use it for their computer or regression model. All right, let me go back to A and B. Huh? No, of course not. All right. Any questions before I stop this event? Like I said, it's a short event. I went over a very high-level overview because, like I said, ML is big. You don't fear that you're not going to learn it all, because even the experts don't know it all. So take it one step at a time. I'll go back to the steps I showed. Take a picture. So learn the fundamentals first. The Andrew NG course, please. Look it over at least like the first 10 videos. Find a tool and use it. There are a lot of resources for these tools. Tensorflow has their own guides and stuff, but you can also go into books or YouTube videos. Free Code Camp has a video on Tensorflow. It's kind of outdated, but it does its job. Figure out your area so you can specialize this. It's in the Discord, Casey. I posted it. Man, I don't actually have it here because I'm not signed in. But it's definitely in our Discord in the AI channel. Join GDSC. And if you have any more questions, you can DM me. I'll put my Discord tag in. Whoop. And I opened up the dictionary. And I opened up, jeez.
What are you doing?
I think I just closed. All right, I guess we're stopping the stream there. Here's my Discord. Send me any questions there. And now we can stop the stream.
Do you want to go back?
Yo, I used to have a Mac, but it was an older one and an Air, not a Pro.